Hello, this is Mrs. Taylor, and I'm going to introduce you to the derivative of exponential functions. So the two rules are the derivative of e to the x is e to the x, and the derivative of e to the u is e to the u du. So when you have a composite function, so the exponent of e is something other than just x, it's an expression, then you need to use chain rule, which would be taking derivative of the outer, the e, leave the inner alone, times derivative of the inner. So that's where this du over dx comes from. So if we apply this rule to these two problems here, I have the derivative of e to the 2x minus 1 with respect to x. This would be an e to the u problem, so first you would write e to the u, and then multiply that by the derivative of u, which would be the derivative of 2x minus 1, which is 2. So it would look like this. E to the 2x minus 1 times 2, and usually you don't see it written in final form with that 2 at the end. Usually move it to the front. So the final answer is 2e to the 2x minus 1. And then this problem here, we have e to the negative 3 over x. So this is the e to the u. I would use the e to the u du rule. So just rewrite e to the u first. And then I would need to multiply by the derivative of u. And this is the same thing. This negative 3 over x is the same thing as negative 3x to the negative 1. So I can use the power rule. Multiply negative 3 times negative 1. That would be 3. And then subtract 1 from negative 1, which would be negative 2. And so my derivative would be 3x to the negative 2. And usually in finalized form, again, we don't leave the 3 at the end. The coefficient moves to the front. And then this x to the negative 2, sometimes you'll see it written as a denominator. So one version of a simplified answer may look like this. 3 times e to the negative 3 over x all over x squared. You could also move the e to the denominator and get rid of that negative as part of that exponent. So lots of options with simplifying this one. But that's how you would apply the rule for exponential derivatives. Now there are cases where we are working with exponentials bases other than e. And so in that case you might have 2 to the x, 3 to the x, 4 to the x, or 2 to the x minus 1. And so in those cases, these would be your rules, where the derivative with respect to x of a to the x equals natural log of a times a to the x. And so the derivative of a to the u would be natural log of a times a to the u du. And so these are rules you just have to memorize. If I'm trying to find the derivative of this first equation here, y equals 2 to the x, I would use this first rule. And so dy over dx would be natural log of 2 times 2 to the x. And then this bottom equation, this would be a composite, so you would use the rule that involves u. And so it would be natural log of 2 times 2 to the 3x times the derivative of 3x, which is 3. And then to simplify, we usually don't leave the 3 at the end, we bring it out front. And that moves into territory of your natural log properties. So if I move that 3 out front of the natural log, then one of the properties is that if it's a 3 out front of a natural log, then it's an exponent of whatever you're taking the natural log of. So that means this 2 actually becomes 2 to the third. And then, of course, we don't leave it as 2 to the third. We simplify that to 8. And so my simplified answer for this would be natural log of 8 times 2 to the 3x. And so in addition to these new rules, you also have to remember your properties of exponentials and logarithms. And so that's the two rules you need to know for finding the derivative of e to the u and a to the u.